Good morning, everyone. Oh, come on, really? It's early for me, not for you. Try it again. Good morning, everyone. Thank you. Yeah, this is going to be interactive. Sorry. I'll apologize up front. My name is Dave. Yes, I am an engineering director at Google in our SRE, our Site Reliability Engineering organization. Quick show of hands, who's ever heard the term SRE before? Oh, yeah, that's pretty good, actually. Thank you all very much. For those of you who haven't, the SRE org, the Site Reliability Engineering org at Google, we're the production engineering team. We're a group of software engineers responsible to make sure all the things work. The data centers run, the networks work, the software compiles and deploys. We carry the pagers. So that is my day job. That, and I do some other things too, including network capacity planning for Google's network. My day job is not building slides. So you can cast your eyes there. That is the only slide in this deck produced by marketing humans. It's the prettiest thing. It's all downhill from there, I promise. But hopefully the content will be better. I want to talk today about risk, and particularly how making more errors will reduce your risk. Yeah, I know it's counterintuitive. I am going to say some things that some of you are going to disagree with. That's okay, because they were all things I disagreed with, or many of them were things I disagreed with just a few years ago. But we'll work through this together. So let me start with a simple question, because it's early in the morning for everyone. How do we define humanity? Meaning, what does it mean to be human? Yeah, I said the question was simple. I didn't say the answer was simple. I know that seems like kind of a wonky thing to be asking at this time in the morning, but it's actually highly relevant. Right? Cerner is a company that denominates its value at the end of the day in the outcome, the health outcomes of human beings. And even if you weren't, I think we can all be honest with one another, we are certainly living in the AI century, probably living in the AI decade, and maybe even living in the AI moment in the world. I think we all sort of understand that under the guise of machine learning to begin with, but then later strong AI, that the machines are getting pretty darn smart. And so the question is, what does it mean to be human? Because in our lives, in all of our lives, that meaning is going to get blurred a little bit. And yeah, it really does have something to do with reliability and risk, and a lot to do with the work we all do together. So if the big AI ever gets really intelligent and asks me, calls me to the carpet and says, what does it mean to be human? I will probably point the machine at this. This is a poem by a British author, Alexander Pope, first published in 1711, called An Essay on Criticism. All right, quick show of hands. Has anyone in this room ever read this poem? Maybe it was forced on you in high school, or if you're a humanities major. I have one person in front. I think that's it. I'm surprised to even get one. Congratulations to you. This is a fascinating work. It's not very long. It comes in 3 parts. It's highly readable. And what's really interesting about it is it's a kind of a work nobody can name, but everybody knows. All of you, everyone in this room knows this poem. For example, perhaps you've heard the phrase, a little knowledge is a dangerous thing? Yes? No? Okay, no, we'll see. Let's try the next one. How about fools rush in where angels dare to tread? We all heard that one? Or my personal favorite from the end of part 3, to err is human, to forgive divine. Be honest, how many of you thought that was Shakespeare before right this minute? I know, when I read this at 15 or 16, I thought it was too. Someone ever asked me, what does it mean to be human? Some alien comes to Earth and asks. That's my answer. The essence of humanity is to make well-intentioned errors. Really, we can boil it down to that. You know, if you want to be very philosophical about it, you can say, no, you know, the purpose of humanity is to strive and learn and grow. Yeah, but our main tool for striving and learning and growing is making mistakes and learning from them. That's it. You can sum it up, in my opinion, in exactly that. Now, Pope was not the first person to observe this. Seneca the Younger, actually, was a Roman philosopher, one of the sort of holy trinity of the Stoic philosophy. I'm going to butcher this, by the way, for those of you who speak Latin. My Latin is pretty awful. Errare humanum est, sed in errare perseverare diabolicum. Quick, what's it mean? No. You. To err is human, errare humanum est. But to persist in error is diabolical. What he means is, it is the most human thing, and it's the definition of it, to make mistakes, well-intentioned mistakes. But once you know you are making a mistake, once you are persisting in that error out of choice, because, well, you know you've made a mistake, maybe because of pride, right? I think we've all kept doing the wrong thing, however you want to define wrong, out of pride or stubbornness, or in my case, sometimes laziness, or maybe just because you don't know what the right thing to do is, so you keep doing the wrong thing so you can do something. Seneca's point is that when he says diabolical, he really means not human, meaning anti-human, inhumane, you can think of it as. Right? It means being contra the nature of humanity, to persist in error. And there, I think he is right. It's a pretty good philosophy to live by. Actually, it's a pretty good production philosophy. But maybe that seems a little, I don't know, highbrow for a tech talk. So let's do my favorite thing in the world. Let's run an experiment. I'm so glad everyone had to stand up a few minutes ago because this will seem less weird. But I'm not going to make you stand up. Everybody in the room right now, raise your left hand. High up. Let's go. Okay. Lower your arm if you have been a Cerner employee for less than 90 calendar days. Put them down. Okay, thank you. Still got a lot of hands. You may lower your arm if, in the last 90 days, as a Cerner employee, you have been perfect on the job. No mistakes, big or small. Really? That many of you think you've been perfect in the last 90 calendar days? Wow, you could raise your hands just now because of hubris. All right, last 60 days. You've been perfect as an employee the last 60 days. No mistakes, big or small. You didn't actually accidentally call someone named Gregory Tim. Last 30 days. You've been perfect in the last 30 days. No big or small mistakes. Last 7 days. Last 7 days, you have been a perfect employee. You've made no mistakes whatsoever, big or small. All right, well, thank you for your honesty. Put your hands down. That's a lot of hands in a 4,000-person organization that were still up. And that's okay, right? Making small, well-intentioned mistakes is the essence of what it is to be human. I like to say that we haven't made errors, we have expressed our humanity. But you might wonder, 4,000 people in this room, in a company that's roughly 25,000 people, I think, that's a pretty good population sample size. If there are that many hands up in the room, that's a lot of well-intentioned errors that are happening in the company all the time, every day. And they're interacting with each other in unexpected and weird ways. Good Lord, how does this company survive, much less thrive in the way that it has? It's a little scary when you think about it, except it's not. Most mistakes that humans make are small. They have very little impact area, blast radius. Therefore, the mistake I make and the mistake you make are actually pretty unlikely to interact with one another, causing some sort of chain reaction or cataclysm. And the mistakes we made tend to be temporal. That is to say, we make a mistake and the effects of it wear off pretty quickly. We correct ourselves or just it wasn't that big a thing. That's a very important thing to keep in mind as we get into this, to the meat of the thing. Before we get into the very technical bits, this is the point I'm trying to make. When we embrace our fallibility as people, when we understand the essence of what it means to be us, in fact, our opportunities to learn and grow come from the well-intentioned mistakes that we make. That's how we embrace our humanity and how we advance as employees and as a company, as people serving patients at the end of the day. All right, before we dig in, I'm going to have to define a couple of terms. You're going to hear me talk a lot in the next 30-ish minutes about reliability. Now, when I say reliability, that can get very specific. I might mean availability, that is to say that when I want to use a system isn't there. Or I might mean correctness, does it give me the right answer? Or I might mean latency, how long does it take? Or I might mean error rate, meaning when I go to use it, it doesn't choke on me. Those are all properties of reliability. I don't mean any of those specifically. What I really mean to say is, for the purpose of this conversation, we can think of reliability as the likelihood that when my user goes to use a system, it will work as they expect and need. Nice, simple, sort of intuitive definition of what it means to be reliable. We are meeting our users' expectations. Or if you could think about it another way, the likelihood that when my user uses a system, they will not become unhappy. We could think of it that way, too. One more thing. Every company has its own terminology. I'm going to use the words customer and user and client pretty much interchangeably over the next few minutes, okay? I don't want you to draw too deep meaning into it. I said earlier there are going to be some things we disagree on, but let's start with a thing I hope we can all agree on. Reliability, at least as I have defined it, is the most important feature of any system. And when I say system, I don't just mean a computing system, a process, any process, by the way. Right? If a thing consistently makes your users, your customers, your clients, unhappy, what will happen? Well, they won't trust it. If they don't trust it, what will happen? They won't use it. If they don't use it, you know what you have? You have a system with no users. There's no such thing in the world as a very valuable system with no users. It doesn't exist. There are very valuable systems that don't get much use. The airbags in your car are a very valuable system that hopefully doesn't get much use. If it does, you should really think about the bus. All right? I don't think that's terribly controversial. A few other things I think we probably all agree on. The first is humans are awful computers. We are terrible machines. You give a large collection of people simple instructions, some fairly predictable percentage of them will get it wrong. For example, if I said raise your right hand or raise your left hand, about 25% of you raised your right hand because you saw me raise my right hand. Right? You heard the words, saw me raise my hand, you figured that was good enough. And that's okay. Like, that's completely and absolutely expected. Humans are terrible at following instructions. That turns out to be a feature, not a bug. But don't feel too bad about it, because computers are awful humans. No, it's true. A computer really can't do the thing that makes people people. A computer can't make a well-intentioned error. Yeah, you can write computing systems, models and simulations that introduce randomness at some point, but that is not a well-intentioned error, because it's not an error because it's doing exactly what you told it to do. It's actually very hard for a machine to make something we would recognize as a well-intentioned error and then learn from it. So that's good news. There are actually large classes of things, mostly in the category of making mistakes, that computers will never, ever, ever replace for us. I should also clarify a couple of definitions. People, everyone, we all, me too sometimes, tend to confuse two concepts which oughtn't be confused: judgment and intuition. They're actually different, and it's important in this context. Judgment is what we use when when we have to make a decision and there is no more useful data to get or no more time in which to get it. Judgment gets better with experience. Intuition is what we use when we could get more data or spend more time and don't want to. Intuition actually doesn't get better with experience. I don't have the time to go into it, but if you ask me later, I can talk about experiments that have been run that show that human intuition isn't much better than chance, by the way. So all those people telling you to use your gut aren't really thinking this through terribly. And it's not always easy to know the difference between judgment and intuition. The easiest test for you is, if I wanted to, could I get more useful data to make a decision or spend more time and actually advance the thing? That's a hard thing that takes experience to sort of figure out. But it's an important distinction, because computers aren't good at judgment. They're terrible at it. Computers are fantastic at intuition. Because if human intuition isn't much better than chance, I can program a computer to flip a coin. and get essentially the same result. All right, I don't think we'll get a lot of disagreement on that. Okay, here's where some of the disagreement's going to come. And I will start by saying, not many years ago, the words I am going to say, which I really desperately believe are true, I would have vehemently disagreed with too. But here we go. You ready? If you set a goal that involves humans anywhere, so basically almost anything, and your goal is 100% success or 0% error, you have set a bad goal. All right, no one's thrown anything at me yet. Good. Now, I mean that very literally. It's not that it's just that it's bad because it is unachievable, right? We know anything involving people is going to introduce error. That's the nature of humanity. And because it's not achievable, it's not practical, so why on earth would you set a goal that isn't practical, right? But it's worse than that, actually. It is, if we think of Seneca's definition, inhumane. We have set a goal that is contrary to the nature of what we are, which is in fact what makes it unsustainable. And so in a sense, it makes it immoral. Now, if you're an executroid like I am, maybe you've had the morality beaten out of you, and so you don't care so much about that. That's in your third week of onboarding at my company. No, I'm kidding, actually. That was when I was at Amazon. It's not, I'm less kidding about that. If really what you only care about is the bottom line, that's fine too. How about this? A goal of perfection, which is really what we're talking about, is bad business. Full stop. Why? Well, let me look at my notes and I'll tell you. No. It's bad business because it's wasteful. People are going to make errors. Errors are our opportunity to learn and advance. If we demand perfection of them, we demand they make no errors. That's actually not really what happens, but we'll get to that. Which means we demand they don't learn. We demand that they don't advance. And that's anti-progress. So it's bad business because you can't grow. But here's the worst thing, and this is the thing that finally kicked it over for me, because when I first heard this some years ago, I argued against it because I had goals on my team, 100% customer satisfaction. That was a goal I had. Turns out to be a bad goal, a counterproductive goal, bad business goal. Why is that? The answer is it makes honest, hardworking, well-intentioned employees dishonest. It says to an employee, I have set a goal for you that I might not, I tell you I don't expect you to hit, but I expect you to get better, which means I do expect you to hit it, really. And after some point of performance, I know you're going to lie to me because you are going to make errors. We're all going to make errors. And so you're going to create a set of metrics that say we've hit 100% by some definition, but they won't be a really honest set of metrics. And I'll know it, and I'll accept it and pass it on, which makes me part of it. And that was entirely unnecessary because what I've told you, I've created for you a set of incentives that says in order to survive in your job for any long period of time and continue to improve, at some point of progress, you have to start being dishonest. Now, I know that's jarring. I do. I swear I do. But it's true. And that kind of melted my brain 5 or 6 years ago when someone first said it to me. Because then I looked back at the places where I had been successful with teams and where it had kind of fallen over. So customer satisfaction is a great one. You run a support team, you want 100% customer satisfaction. It's a common goal, most common goal. You get to 80%, you're feeling okay. You get to 90%, you're feeling better than okay. You get to 95%, you're feeling really, really good. But somewhere above there, north of there, and that will vary for people, you reach a line, a magic line, that you can't cross reliably and reasonably. And so what happens? The people who work for you start getting a little looser. Like, here's a common thing that happened. I discovered the hard way. You know, we would send surveys to people after we helped them resolve a ticket. Okay, pretty common, except we didn't send it to everyone. Our agents were gaming the system. They were only sending the surveys to the people who seemed pretty happy. Yeah, I hear the mumblings in the audience. I know what that means. Don't feel bad. Please, don't feel bad. Right? This is a standard we try to hold ourselves to all the time, but you have to first embrace the idea that it turns out to be a counterproductive idea, a counterproductive thing to do on a lot of levels, and it drives bad behavior, and it impedes progress. Let's talk about that magic line. There is a line of performance. It's very distinct and very clear and very crisp. For any system, we can think about it as an amount of reliability, as we've defined reliability this morning. And it has a fantastic magical property. If you are much below that line, that magic line, your customers will be unhappy and let you know it. If you're very far below that line for any period of time, it'll be pitchforks and torches and flipping cars in the parking lot. And you will not last long in your job. That's just truth. But here's the other interesting property of the line. When you get over the line, your customers are indifferent. They don't really care how much over the line you are. We can see this is a real thing. You can use data to see this. Let's go back to our example of support. If you are lucky enough to work on a system where you have a feedback loop from your customers, say in the form of support tickets, you can plot your reliability and your CSAT, your customer satisfaction, right? And you'll see as your reliability goes up, the CSAT goes up and up and up and up and up, and then at some magical place, it flattens out, almost perfectly horizontal. It's a deep, deep knee. That's where your magic line is. And that is what you should be operating to for all of your systems. You should be aiming to run the business and run the systems so that they are just a little more reliable consistently than the magic line. Should defend the heck out of them so they aren't under the line much, but that is the goal. So then how do we reason about the space between perfection and that line? Well, we call that the error budget on purpose, because it is a budget. You should spend it. You should take your nines for a spin, as we like to say. That is to say, it is the volume of error, or in my formulation, the volume of humanity, volume of learning you are permitted to do while still keeping your customers happy. Which at the end of the day is the result you're looking for. Like, you know you're doing well in the business if customers are genuinely happy with you. So that's what we call it. We call it an error budget. And there's a good reason to think about it this way. Every increment of progress above the magic line is exponentially more expensive in time and effort. So if the magic line for some system is 99% reliable, whatever that means, and you get it to be 99.5% reliable, okay, well, you've underspent your error budget. But if you put more work in to get it to, say, 99.7 reliable, that extra 0.2 will have cost a bunch more than that original 0.5 did. It's hugely supralinear in the cost. Let's say it's very exponential. And we can see this in the data. So you're wasting a huge amount of opportunity that you could invest in other places, in experiments in that system or in other parts of the business, by underspending your error budget. And obviously, if you overspend your error budget, if you're less reliable than you need, your customers are pretty unhappy and they will tell you about it. Okay, I need to introduce a few more terms for this to make sense. First term I'm going to introduce is SLI, Service Level Indicator. A service level indicator is a thing we measure, a metric we measure, from the perspective of our user, which would tend to tell us if they are happy with us or not, or how they're experiencing a system. Let's say you have an online system and doctors can go pull up patient records. A thing you might track is when a doctor clicks the button to pull up the current medical history for a patient, how long does it take to load, say, 95% of the time? That's a thing, that's a latency SLI. That's a pretty reasonable thing to want to know. That's an SLI, a service level indicator. A service level objective, that's the number we would like to see in our result. It's just an SLI plus a goal. So 95% of the time when a physician clicks the get patient history thing, we want to see the data come back in less than 200 milliseconds. That's our goal. The SLO, The magic line we were talking about, that's what that is. That's called the SLO. That's your service level objective. Your goal should be to run the service reliably a little above that line. Never consistently a lot above that line, because you're wasting opportunity, and certainly not below the line. And that's the science of production engineering, to be perfectly honest. There's another term, however, that we need to do. Commonly, people know SLAs, right? Everyone knows a service level agreement. SLOs, service level objectives, are not the same as SLAs. People confuse them, and why wouldn't you? They have 2/3 the same letters. They mean the same things. Seems perfectly reasonable pattern match, but they're not. A service level agreement is a contract. It's a legal agreement your lawyers and salespeople usually have helped devise between you and your customer that says if you do not perform to a certain standard, they have a certain kind of remediation. Maybe in service credits or who knows what. But there's a penalty. It'd be nice if your SLOs and your SLAs were connected. In a perfect world, all of your external SLAs would be your internal SLOs plus a buffer plus a consequence. But in reality, it often doesn't work that way. And so when we talk about reliability, we don't usually talk much about SLAs because SLAs are outward facing to the customer. They're legal contracts. SLOs, objectives, and SLIs, indicators, are inward-facing. They are metrics often you don't usually, actually, you don't share with your customers. Occasionally you might share it with some stakeholders, like regulators. But they're inward-facing. We use them to measure how well we are doing as we engineer and operate these systems. All right, we've talked a little bit about what happens when we consistently underspend the error budget and why that's bad, right? Because we're wasting opportunity. What happens when you overspend it? Let's say we have a goal. Our system has to be 99.9, so 3 nines, reliable over some 30-day measured window. Whatever reliable means, whatever our SLIs are be, but that's our SLO, right? Okay, we have some number of SLIs that aggregate into it. Well, heck, let's do 4 nines, 99.99. You have an error budget of 4.32 minutes every 30 days. That's your budget. That's how the math works for that. Okay, so what happens now if someone makes a change and you have a 9-minute outage? How do we handle it? What's the consequence? Well, the way we do it, the way we encourage people to do it, because the way it works best, we have found, we believe, is there is a known consequence ahead of time. Right? So the most common consequence is that there's a feature freeze. A software engineer pushes a bad configuration into production, let's say. We have a 9-minute outage. It will take us an extra 30 days to earn back those minutes, right? We have spent 60 days of budget when we only had 32 spent. So we're going to be feature frozen for all non-reliability features for 30 days. So we might spend that time building configuration checkers, or we might be adjusting the rollout policy so that the blast radius of a bad configuration is smaller. Or we might be tightening the monitoring, or alerting, or whatever it happens to be. And that is the fundamental relationship. This is the most important thing. So once you have an error budget, the rule is when you blow the error budget, you have a consequence. A freeze is the simplest consequence, and it's the one I most advocate because I think it's the most effective. So let's say we have a freeze. You have a freeze for the amount of time it takes for you to recover, to earn back your budget, right? It's like having to pay off a credit card. That's a very important dynamic. Because you see, let's see, that's my next slide. Sorry, I have a policy that no one gets the same talk twice. Actually, I don't do the same talk twice, so that means I almost never know what my slides are. Well, all right, we'll get to that bit in a second. Let's do this. Most common thing that I hear from folks after we talk about what happens when you blow the error budget is, well, it wasn't my fault. What do you mean it's not your fault? Well, I'm running this system here, let's say a web, the web UI, and I rely on, 3 systems deep on a storage provider that's a platform in my company. It's not my fault. My answer is, who doesn't care? The customer. They had an outage. No. I have never, ever, ever seen an outage where systems that depended on one another each couldn't do something to have made it better. I'm running a system and it relies on a database, and the database has a problem. Well, it's not my fault the database had a problem. No, it is. You designed a system that relied on a thing that had less reliability than you needed. What could you do to mitigate that so you don't have that problem anymore? Maybe you could cache it. or something. Even there are instances where serving stale data is actually an appropriate kind of thing to do. The point is there's always something you can do, and your customers don't care what your internal dependencies look like, so you should get out of that mindset. And while we're at it, we should stop using the word blame. Just all right, well, I'll use the hand mic since wow, that was more controversial than I thought. They actually cut me off. I was waiting for security to come to stage and escort me off. Thank you for coming. All right, that's why we have backup systems. N+1 mics, fantastic. All right, banish blame from your vocabulary. Let's play a game, okay? I'm gonna give you a fictional scenario. I want you to tell me whose fault it is. There's an outage. Here's what happens. Adam is a data center technician. He's walking on the floor one day. He trips over a power cable that is plugged into a blade server. Betty installed the blade server, but she didn't screw down the mounting brackets. In the chassis, the server goes flying out of the back of the chassis into the wall, smashes it into a bazillion pieces. Charlie is running a back-end service on that blade server, which is now toast. But Charlie was only single homing it. Like he didn't have it running in another one, he wasn't load balancing. Danielle is running a front-end application. He's running a front-end application that depended on Charlie's back-end service. And of course, our customer, I don't know, Ed, let's say, if we're keeping in the alphabet, has an outage. Whose fault is it? You could say it's Adam's. He kicked over the cable, should have been a little more careful. You could say it's Betty. If she had just screwed it into the chassis better, it wouldn't have gone flying. You could say it's Charlie. Charlie should have known better than to run something on a single instance. You could even say it's Danielle, like, you know, you should expect that the thing you depend on might have a problem now and again, and you should account for it in your UI. All right, so I think you could pick somebody in there if you wanted to. If you're feeling particularly clever, you'll say it's everybody's fault, right? Actually, it's nobody's fault. It's the system's fault. See, when you make it somebody's fault, you blame them, two things happen. One, you say, I know you're human, I know you're gonna make well-intentioned mistakes. It's not like Adam got mad and kicked the cable on purpose, or Betty just was lazy. That's not, almost certainly not gonna be true. So by blaming you, I'm denying you your humanity. Now, if you don't like that, if that seems a little too ethereal, how about this? When you look to blame humans, you don't learn anything. Because the humans who contributed to the thing, or who happen to be the unlucky victim, who happen to be in that spot at the moment, don't raise their hands and tell you the truth. If you do postmortems, as we do, whenever we have a production outage, they don't contribute. They clam up, they start thinking about how they can shift responsibility, and you don't learn anything. Now, your customer had an outage. Your customer experienced an error. That is painful. You've reduced your customer's trust. You have less wiggle room with your customer at that point. That is extremely expensive in the sense that if you squander that up as an opportunity to learn, you have done a grave disservice to your business. So it actually follows that if you're going to have an error budget, and you should, that when there's an error, the view should be the humans involved were just the poor unlucky souls who happened to be there right that minute. And it's the system's fault. And so we ask, what is it about the cabling system that permitted a power cable to be on the data center floor as opposed to under it? What is it about the racking system that would require a human to screw something in instead of snapping? What is it about the software deployment system or the load balancing system that didn't detect that Charlie was single-homed on a service? What is it about the UX framework, the web framework that Danielle was using, that didn't have data caching built into it automatically? You blame the system, not the humans. And when you do that, you get a better result all the time. Now, you can say that, you can even live it, but you're going to have to do a few things to really enforce it. So, for example, here's the thing we do, which I like. We celebrate our mistakes. Every month, we get together and we talk about our greatest hits or our greatest misses, usually. Like, we didn't plan a thing and there was an outage in South America or something. And we talk about it openly and honestly. And it's never from the perspective of this human. In fact, it's the human who was unlucky at that moment, usually getting up and presenting. We do something else, which I would strongly encourage you to do. We have performance reviews twice yearly at Google. It happens to be our cycle. Every performance review cycle, we go out and look for the following story, because in a company of 100,000 people, give or take. It's pretty easy to find. We look for someone who was an unlucky human. They pushed a bad configuration. And a bad thing happened. There was an error, a well-intentioned error. And they raised their hand and said, oops, I think that's me. Let me help you mitigate that. And then they went and designed, wrote a design doc about how to mutate the system so the system wouldn't allow that anymore. And then they went out and changed the system or helped other people change the system, depending on who owns it. And then later, some other unlucky human made exactly the same mistake because it's a metaphysical certainty there will be, except the system caught it this time. We look for that first unlucky person. And whether they'd asked for it or not, we promote them. Really. At Google in performance management, you got to tick a button that says, I feel like I would like to try to be promoted this time. Your manager doesn't tap you on the shoulder. And this is the one exception where that's true. Where the manager will really say, congratulations, whether you want it or not, you are promoted. Why? Because you exemplified exactly the behavior we need in production, right? You owned it. You weren't ashamed of it. I mean, you might be a little embarrassed by it. We'd like to see you not habitually making the same mistake. Actually, to be very clear about it, let's say I'm just a terrible employee and I am habitually pushing bad configurations that are breaking production. My sin is not habitually pushing bad configurations. My sin is at no point, having pushed a bunch of bad configurations, did I change the system so that I couldn't do that anymore. That's my actual problem. If you do these things, you will discover this fact, that reliability and speed are not enemies. Most of you probably think that your speed and your reliability, if you were to plot them, are an X, right, that they push on one another. Not true if you do this. What you find over time is actually your reliability and your execution speed go up. You can make more errors, but lower your overall risk. This is really important. So depending on how you're organized, if you have separate production teams from your normal developer teams, right now they fight with one another all the time, right? It's tribal warfare. The production team is creating more hurdles for developers to put things in production. The developers are, getting around those hurdles. No, it's not a feature change, it's a flag flip or some other thing, and they're fighting. It's tribal. Doesn't need to be that way. If you have policy and you have error budgets, and you're observing them in a blameless postmortem culture, what you find is those teams work together much better. In fact, over time, you will find that by measuring your reliability, you can work backwards into your speed, or by measuring your execution speed, you can work backwards into your reliability. My last point, I know I see I'm 27 seconds over time. It's going to be fine. They told me I could run a minute long. I work with a lot of companies in regulated industries. Medical device manufacturers are a good example. Adopting principles like these, so in my case, I'm here to preach the gospel of SRE, your regulators will appreciate it. I know this firsthand. I was talking to a regulator at the FDA, having a conversation with him in the context of a medical device company, and I was explaining SRE principles to this person, explaining SLOs and SLIs and error budgets and accountability, and he looked at me and he said, thank you, yes, that's the thing. He said, you see, because when the risk regimes for these companies were set up, software didn't contribute much to the risk surface. Financial controls contributed to the risk. Hardware design and change management contributed to the risk, but software has eaten the world. And so since everything's got software now, software development practices need to be connected to those risk regimes, CMI or ITIL or whatever. And there hasn't been a good way to map it down. Well, it turns out these principles and more, SRE, map backwards into those regimes really well, and allows you to give your regulators and other stakeholders a level of transparency they couldn't get before. And they will appreciate it and reward you for it. I have seen this in financial services and medical devices and so forth. All right, this is a deep and rich topic. I'll leave this slide for like 2 seconds so you can take a picture if you want to. There are a couple of books. This is the shameless self-promotion section of the conversation. That first one on the left, the SRE book, we published at the end of 2016. The one on the right, the Site Reliability Workbook, will be out next month. They are good starting places. The one on the left is actually online for free. So there's really not an excuse not to go look at it. I am out of time. A couple of quick things, though, a last word here. One, in this forum, we don't do Q&A, but I'm going to hang out for a few minutes afterwards, so you can come and tell me all the places I'm wrong. I would like to hear it, really, seriously. Also, you've been wonderful sports, really. raising your hands and listening to what I have to say. I could tell, looking in the crowd, that some of it were things you were thinking, yeah, that guy's full of nonsense. That's not true. But I do appreciate you giving me the opportunity at least to say it. And so with that, I guess the final word is just this. Thank you. It's been a lot of fun to be here, and I really look forward to talking with more of you today. Thank you very much.